Okay, morning, everybody. Welcome to our early morning big data class. Good job for waking up early and being on time. We'll start with just do one of the homework problems from the Pagilla homework, so that can be the reward for being on time, as well as you get to see the answer to one of the problems. So again, down here, I'm in the proj/Pagilla homework folders where we were working last time, and I have a Docker container that's running, and if I do docker compose exec pg psql like this, then I can connect to the Docker container up top, and then down below we can open up one of the problems. We looked at a couple of these problems last time. We'll jump ahead to problem number 14 this time. One of the, maybe the harder, I guess harder as they go along. And the key idea here in these latter problems is that there will be multiple tables that need to be joined together in order to get the right answer. And so the idea of this problem says list all the films in the family category. And so let's remind ourselves exactly, here it is. So we have the film table right here, and then there's this category table up here, and this film underscore category table links them. And let's just go ahead and take a quick look at select star from category, what kind of things there are in there. So it's things like action, animation, children, like sort of genres maybe is another word for these. And any film can belong to more than potentially more than one genre. Eventually, maybe 2 or 3 class sessions, we're going to start talking about like why you might structure your database in a certain way in order to achieve certain ends. But this is a common pattern that we'll see where we have a table, like a category and a film, and we're trying to link them together somehow with like a film underscore category table that has basically nothing inside of it except it's got a film ID linking in the film and a category.id linking in the category up here. And what this is going to do is it's going to allow us to have multiple categories per film or multiple films per category. In order to solve this problem, so it's we want to list all of the films in the family category. So we'll start by, so the film's title is like the name of the film. So select title from film. And then I have to somehow get from the film table to the category table. Down here, I'm specifically telling you sort of like the path to take, go from film to film category to category. But in general, if I didn't give you the particular path to take, you'd know that here's the end table that we're trying to get to, here's the table that we're at, and so we just have to follow these little lines to connect them. So we'll join film to film category, join film category, and we'll join on film category dot film ID equals film dot film ID. This film ID right here, again, is the, it's in this both this film table and this film category table. Whenever we have 2 columns with the same name in 2 different tables, we have to tell SQL which table to look at, and that's what the stuff to the left of the dot is. It's the table that we're looking at. So this is the film ID in the film category table. This is the film ID in the film table. Join that. And this is a really common pattern we said last time. So you don't have to use this on anytime you're joining two tables that have the same column inside of them. Instead, you could do join. The next one we're joining with is category. And we can use the using category ID like this. Using is equivalent to on left table dot right table dot for this column, and category ID is in both of these. Category ID, film category ID right there. And so we can do that, and there's our list of all of the titles. Any questions about that? Done?
I'm just wondering, since for a table, each row has its own ID, right? Or is the prime ID a private? Oh.
Make this bigger. Oh, there we go.
Oh, I see. Sorry about that. I thought they have like ID column and another separate prime ID.
Okay. Any other questions about sort of that process that we went through in order to connect the film to the category table? Okay. So yeah, before we move on, one last thing I'll mention about this is, so here this using is a special sort of syntactic sugar for on. And there's another type of syntactic sugar that it's also really common to do joins on a column that is present in both tables, where there's only one column that is present in both tables. And that is called a natural join. Natural join uses all the columns in both tables with the same name as the join condition. And so up here, this join, or this big select statement right here, I'm going to edit this and change it to use the natural join, which is a little bit simpler. In order to edit my previous query, the last query I typed in, I do \E, and it opens up a Vim window where I can edit using Vim. And since this is a multi-line query, it's pretty long. Vim is a much nicer environment to do this in. And so I can type natural join, film category, get rid of all that junk, and natural join category, get rid of all that junk. Save that. And that didn't work. We're gonna rerun that command in order to do \E right here, get this one back, change this last one to the natural join. Okay, well, apologize for that. I'm not sure off the top of my head why that's giving us 0 rows. But yeah, I guess in my solutions, what I'm doing for everything is using this using and then the column name right here. Okay, so yeah, that's the answer to problem 14 on the Pagilla homework assignment. Again, that homework assignment is due, we've covered everything that you need for that homework assignment at this point, and it's due on this coming Sunday. For today, we're going to do that a little bit. I've added a week 4 folder, so that's where we're starting with today. And inside of here, there is a Pagilla Homework 2 folder. So everything that we're talking about today and Friday will be related to the Pagilla Homework 2. But again, this homework will not be due this coming Sunday, but a week from Sunday. So some quick announcements. All of your previous homework has been graded and put in Sakai. Most people got full credit on the homework. A few students were missing important files, maybe like 3 or 4 students, and you got points. And you missed points. I'm willing to regrade this for you if you think somehow it's just like a mistake with Git or you weren't sure exactly what to upload. So check your grade and contact me if you'd like to get that regraded. But also recall that you're allowed to submit late. So a handful of students haven't submitted yet. That's totally okay. You're allowed to submit late. And if you do, then it's just a minus 20% per day penalty. And in general, it's usually better to submit a correct assignment late than an incorrect one on time. Another great announcement. So this week only, you can redo that POSIX shell quiz. So during office hours, that'd be today or Friday, I have a new version of the quiz all ready to go that you can take and upgrade your grade to up to a 9. Also, I was giving the option for a regrade on the very first lab assignment. There's 3 students who have not taken me up on that yet. Today is your last chance to do that if you want to regrade that assignment. And then everybody did pretty well on the most recent assignment, the median grade has gone up. Another update about TAs in this class. So I apologize for this, but it seems like there's not going to be any TAs for the class. That the only people who are eligible to be TAs for this class in the sense that they've already taken it are at MUD, and for whatever reason, CMC has decided not to hire them. So I apologize for that. And last thing, at this point, we would normally do a quiz on the joins, the SQL joins. But instead of doing a quiz, I thought we would do a take-home exercise instead. So in the back, if you haven't picked it up yet, there's a file or a printout back there that says take-home exercise at the top. It's got 6 SQL questions on it. You're allowed to use whatever resources you want to complete these questions. And in particular, you are allowed to, here's the instructions. In particular, you're allowed to discuss it with any other person that you want. You're allowed to use the computer, so you can actually just type the things into Postgres if you want to check your answers. But I recommend you at least try to do them first and understand what's going on, not just type it into Postgres and copy it out and be done in 5 minutes. Couple of motivations for having this be a take-home thing that you can check your work on rather than it being a quiz. The root sort of motivation, though, is because, again, my wife is pregnant. We're going to have, so the due date for the baby is 2 weeks from today, but she just had an appointment with the doctor yesterday, and the doctor said that we should expect the baby any day. And so it wouldn't surprise me if the baby came very early. And so I don't want to schedule a quiz and then have to cancel a quiz, or and we're already going a little bit fast, and so I don't want you to feel stressed out about having to study for the quiz. So that's why it's the take-home exercise instead. But taking it seriously will help you on the midterm, so I recommend taking it seriously. Any questions on any of the administrative stuff for the class? See, everybody's quiet today. I guess everybody's always quiet. Just early in the morning. Yeah. Yeah, I can't do anything about making it not early in the morning. Okay, so on to the sort of material proper for today. Last time, again, what we covered was, so we've gone through the SQL select statement, and we've started talking about these SQL joins, how to use multiple SQL queries, connecting them together. And in particular, we talked about 2 types of joins, the cross join and the inner join. And we saw that the inner join was sort of like syntactic sugar over this cross join. For your next homework assignments, we're going to be, it's sort of like the join super assignment. Lots and lots of complicated joins are going to happen in this assignment. I'm going to open it up just for a second so that we can see here for a second. SQL, so there's 12 problems, but it's really 13 because this problem 6 is divided into 2. And each one of these problems is going to be worth 2 points instead of 1 point because the problems are more difficult this time than they are last time. Maybe let's take a break. How's the first homework going for everybody? Have people started it? A couple thumbs up, a couple shaky hands, no thumbs down. Nobody wants to admit thumbs down. So the material that we're going to be covering today is there'll be a little bit of stuff that's review that will maybe help cement some of the stuff about inner joins that we talked about, but mostly this stuff is new material that is going to be related to the next homework and not the previous one. Our goal is so we're going to get down here on joins, and we're going to be covering a handful of different types of joins. But before we get to the other types of joins, we're going to see something called a subquery. Because a subquery is going to give us the intuition about why we want these other types of joins. And probably in other classes, so if you took like the Foundations of Data Science class, they probably explained like a left join or a full join in terms of subqueries without explicitly using this word subquery. And then when we get down to talking about these left joins, full joins, outer joins, we're going to be doing it in a more formal way than you've probably seen before. And the handout is specifically about like these really weird edge cases that you really have to know these formal definitions for. So even if you think you're like totally familiar with joins, I would wager that you're not, and that the things that we'll talk about today will be different. Okay, so subqueries. Let's come out of Pagilla Homework 1. I'm going to go into my Pagilla Homework 2 folder just for aesthetic reasons. Let's go ahead and get out of the solution branch as well. And there's no difference between these two repositories other than the SQL problems over here. And we're going to start by looking at this one, homework 2 as well. We're going to start by looking at this these basket tables from the createtables.sql file. And again, the origin of this file, the place that I got it is from our textbook from this for this section, postgresqltutorial.com. All of their examples for joins and subqueries use these tables right here with these values inside of them. And I think the explanation that we'll be doing in class is a little bit more formal, but if you want to go back and get the intuition, you can go back and look at these sections here, and it will give you the intuition with the same examples. Any questions before we get started in earnest? Huh?
The insert into basket is actually, is it that insert apple or on this?
So so that's a good question. We didn't actually really cover the syntax of what's going on in this file here. So these two lines up here are creating the tables, creating the relations, table, relation, just synonyms for each other. And then down here, these inserts are inserting the rows. And so what I'm going to do on the left-hand screen, I'm going to pull up or enter pSQL. I did Control-R to search through my history, type pSQL to get back to this command right here. And recall that the \d lists all of the relations that we have. And if I do \g, then a table name, basket A. It'll tell me about the tables that we have for, or that particular relation, what the columns are. In this case, I do not have any of this information loaded yet. I could copy and paste it, doing what we saw last time in Vim. If you want to copy and paste from SQL, you can't just like copy and paste select because you get all these 1, 2, 3, 4s. So in order to do this, I'm going to do :set no number like this to remove all those numbers. And now I can actually just copy and paste and enter things normally right like this. Last time, the way that I did this, getting it loaded up into the database, was using input redirection. So this is just a different way of doing that. And so this, we've just created the table, \d, basket A, zoom out. So created the table, has these columns right here. Again, we'll talk about all the stuff down here a little bit later in class. And then these actually insert the rows, insert the values. And so when I run these down here like this, and now do a select star from basket A, that we have 2 columns, A and fruit, corresponding to these 2 columns right here, A and fruit. And then these are all the A values. A is a number, 1, 2, 3, 4. Fruit A is a, in SQL terminology, all of these would be called text, not strings. But if you say the word string, everybody will understand what you mean, and I will probably say string in this class as well. The particular type of text would be a varchar. Did that answer your question somewhere in there? No?
I was just like wondering because I thought you might also specify the line.
Oh yeah, so these numbers right here, we could change them. They happen to be in order 1, 2, 3, 4. We could change them to be whatever order we wanted, though. That's not required. Yeah, and when we talk about designing the sort of the relations in your database, we'll talk more about how to make these numberings like automatic for you and all the different options in these create tables. But for now, yeah, it's just, these are our columns and these are the values in the column. And we're wanting to talk about this idea of a subquery. So what exactly is a subquery? Well, let's try going vertical for a little bit. So I'm going to do a select star from basket A like this. And so this, so we've seen this before, gets everything in basket A. We've also seen the select star from basket A, join basket B, do on, I guess we'll go sideways so it all fits on one screen. So just moved this so it's up here what I just typed in, select star from basket A, join basket B on fruit A equals fruit B like this. And this gives me this whole table right here. Another new syntax that we haven't seen yet is this star. When you have star by itself, it means select from all of the tables. If I wanted to select all the columns from only a single table, I could do, say, like a dot star. Oops, not a dot star, but basket A dot star. Like this. And this will give me all of the columns just from basket A. And what we're gonna, yeah, so the new syntax we just saw is that the star, you can qualify the star by putting a table name in front, and it gives you all of the columns associated with that table. So that's equivalent to doing A, comma, fruit A. No difference. What we're going to see next is how to do the equivalent of this join right here, how to do the equivalent of this join right here using something called a subquery. And most students, like once you see subqueries, most students think they're relatively intuitive and at least at the beginning, find them easier to use than joins. So the idea is we'll do a select basket A dot star from basket A like this, but I'm going to replace this join up here. I'm going to replace this join with a where clause. Replace this join with a where clause. And inside the where clause, what I'm going to say is fruit underscore A in, and then I'm going to put another query inside parentheses right here. That query will be select fruit B from basket underscore B. And I'll hit enter, and you'll see that these two queries gave us the same results. Now we're gonna look at in detail exactly what's going on here. Why are they giving us the same results? First, we'll start by looking at this subquery inside of this main query and seeing what exactly it's giving us. We call this a subquery because it's another query, another select statement that's just inside of this select statement over here. It's a valid query all by itself, so I can just copy and paste that onto the terminal right here, put the semicolon at the end, and we see that here are all the fruits in basket B. In this command right here, I'm saying, give me everything that's in basket A, where fruit A is somewhere inside of this list right here. Fruit A is one of these things right here. And select star from fruit, from basket A. Let's just check out again what exactly are the things inside of basket A. What are the fruit A's? We have apple, orange, banana, cucumber. Scrolling up just a little bit. Apple and orange are the only fruits in the basket B. And so when I do where fruit A is in all this stuff, the only things that will match this condition here, the only things that are matched this condition here are apple and orange, because apple and orange are the only things in that entire select query. And yeah, and so that's why this gives us those same results as the inner join. Again, that is the subquery version, and that is the inner join version. Are there any questions on the subquery, what it's doing? Does that seem intuitive? Does that make sense? See some head nods. Question?
Yeah. It's actually about the basket A.
Okay.
Store.
Mm-hmm.
So I was wondering, this is an individual. Can we just like remove the basket A and think of the join?
Yeah, question is this basket A dot star, what happens if we remove it? And we'll get, let's see, I'm gonna move this other terminal to a different screen right now so we can see filling the screen with just the pSQL connection right now. We see, so this is the last command that I ran right here. This is the one that uses the join, and this is the one that uses the subquery up here. And in the subquery and in the join, both of them have basket A dot star. If I remove the basket A dot from the star, we'll get different results for both of these queries. On the join query, the star by itself will refer to all of the tables that have been joined together. Hit enter, and we get all of the tables that have been joined together. On the subquery, again, basket A, or the star dot by itself refers to all of the tables that have been joined together, but there's only one table right here. No other table has been joined together, and so that's why we only get 2 columns in the results. A lot of times when maybe more senior people working with databases are talking to each other, we would refer to this query and this query still as being equivalent, because like the rows are really the same. It's just this one has some extra columns, and so it's really easy to convert this one into this one. But technically, they're not fully equivalent because the columns are different. Did that answer your question? Any other questions so far? Jerry?
On the second to last query, if you were to replace basket A with switch basket A with basket B, that just switch the ordering.
Yeah, the question is basically what exactly is the significance of the order in the join? And when you have just like one join by itself and you switch the order, the only thing that happens is that the order of the columns get switched. That the order of the columns when you use star it goes left to right on the tables being joined together. when you have more joins put together, then other weirder things can happen. But with just two, that's all that happens. And if we still had the basket a dot star, it'd be the same results no matter what the order of the tables being joined. Here we're getting the actual order of the rows turns out to be different because, again, we have no order clause. And so we would say these results are non-deterministic in their ordering. And so they may or may not be the same between even individual runs of a query without an order clause. So again, this is something that I would call these results the same results because they're the same up to sorting order. Did that answer your question?
Yeah, but just kind of a follow-up question. So if you were to run the exact same query again, it's not guaranteed that the ordering of the rows would be the same.
That's true. Anytime you do not have an order clause, then there's no guarantee about the output, the ordering of the output. And in particular, you can run it like 10 times in a row and get 10 different results about the ordering, depending on internally what Postgres is doing under the hood. And for a very small table like this, I would expect the results to basically be the same for the same query each time, run 10 times in a row. But if the table was huge, like say on the order of more than 1 million rows inside of it, then I would expect different results each time. And when we get to the like internal algorithms that's going on behind these things, that'll make more sense why. Okay, so this type of subquery where we're using this in clause, the in clause, the in subquery is, I'll put equivalent in quotation marks because it's not really equivalent, but it's basically equivalent. Modulo, all the things we don't care about, is equivalent to an inner join. Maybe actually one other thing that I want to say, I don't think I've said this yet. So here we have our join clause right like this. I've always just been typing out join by itself, but you can type inner join and it's the same exact thing. Just the inner word is optional. So the in subquery is equivalent to an inner join, and then what we'll see next is a not in subquery it's not going to be equivalent to an outer join, but it's like the building block, foundation of an outer join. And the outer join is the thing that we haven't talked about yet, but we're building up to the intuition about the outer join. So let's, once again, so select star from, it's not what I wanted. I want the thing with the in. There we go. So I used the Control R to do my reverse search in the pSQL terminal down here. I typed in parentheses to get back to this line that I was looking for. And so here we have the in, like this, gives us apple and orange. And now I'm going to change this to not in, gives me banana and cucumber. And if we just do a select star from basket A again to remind us what was in there, the apple and orange were in this list right over here. And so the banana and cucumber are going to be the things not in that list. And sometimes it turns out to be useful to be able to combine both of these two queries, the in and the not in query, into a single result. And that's what the left outer join is going to do for us. So we'll start by doing an example of the left outer join, and then we'll do a medium level formalization of it. So I'm going to hit back up to where we had the inner join over here. And I'm going to change this inner join to a left outer join. Again, the outer is optional. I could have just put left join by itself. Oops. And this is the one where we swapped the order. We wanted the A to still be on the left. So here in the left outer join, the two things up here, those are the same as the inner join. So if I delete the left outer and just have join, we have apple, orange, lots of stuff in all four columns, same exact results up here. So this is all the results of the inner join. And then this stuff down here is the result of the not in operator, the banana and the cucumber. Do Control R, looking for the not in, there it is. So selecting from basket A, where fruit A is not in basket B, hit enter, there's the banana and the cucumber. And then in order to make the number of columns match, we only have 2 columns here, no columns over here. We add null values. So anytime you see this empty stuff right here, that's just a null value. There's nothing in these 2 containers, in these 2 cells of the table. And that's what the left outer join is going to do. Combine the inner join or the in operator in subquery with the not in part. Any question?
So how do you, like, in this sense, you select basket A, basket A,
Are you looking at this line?
yeah. Not the only thing that you do, but like for the left hour journey. I'm asking what is the difference between the basket A and basket A?
Sorry, I'm having trouble hearing you.
So I'm saying that, so why if you want to do that select all, you want to do it like on basket A, is it going to bring the fruit from forth or the left hour bring the left to
I'm not sure if this is what you're asking, but the basket A dot star makes it only from the basket A.
Yeah. Now I'm asking what about if this is done by it's like a basket A being there, but it's a left out of line. It's not the point, the left out of line.
This?
Yeah.
Yeah. In this particular case, it happens to give us the same results as just selecting star from basket A. Not in general guaranteed to be the case. But the only difference between this right here and this right here is that we've changed the column list. And in particular, we're only selecting the A columns. So all of these things from the B, just not included in the results, and just these 2 A columns. Did that answer your question? Okay. So again, intuition behind the left outer join is that it is like combining the in and the not in subqueries into one. We're going to formalize that here next by actually writing out these 2 queries combined into one. So the first query saw that the in query can be written using a join like that. And let's bring up the second query again, not in. Here's our not in query. And anytime I want to combine 2 queries together vertically, so the join sort of stacks things horizontally, adding more columns. If I want to combine things together vertically, then there's a set operation called union all that I can use. I'm going to switch back over to the notes here for a second, and just to highlight that these set operations, section 5 of postgrestutorial.com. So I'm going to combine this query and this query together using the union all operator. Before I do that, I want to take a look at exactly what the union all operator does. So let's imagine I have these 2 queries, very simple queries, select 1 and select 2. They just create, so it's an unnamed column because I didn't name it anything. I just have the number here. Has an individual answer 1, individual thing 2 right here. I can combine those together using the union all. Select 1, union all, select 2 like that. And now it just stacks those 2 tables on top of each other. A very important subtlety about this union all operator is the difference between union all and union by itself. In this case, they happen to give the same results. Union all is like list concatenation though. So union all, you should think of it as list concatenation. And union is like set union. That's where the name comes from, set union. And so in particular, if you're thinking about the results of these two commands as sets, then you want to remove duplicates. And so the union command removes duplicate, if I can spell it, duplicate rows. And to illustrate that, if we had both of these being 1, those two 1s are the same. So it doesn't get duplicated, it gets removed. Union all like this. It does get duplicated, does not get removed. This is one of the sort of trick questions that comes up later in this course. It's also on the take-home exercise is differences between union and union all and how they modify your query. So just pay attention that I hate the fact that I have to type union all every time. That's almost always what I want is just normal concatenation. But that's what you have to do. So back to the basket A, and then these two commands, I want to union them together, or more correctly, union all them together. And in order to do that, I will just copy and paste this select statement right here. To make things a little bit nicer, I'll hit enter and then type union all, and then copy and paste this select statement right here like this. And it's going to combine those two things together. The white space here that I added is just like convention to make things easier to read, but again, white space is not an important thing inside of SQL. I'm gonna hit enter right here, and at first we're gonna get a slight error. It's gonna say that each union query must have the same number of columns. So down here, these don't have the same number of columns as this up here, and so it doesn't know like how this should line up with this stuff up here. And so to fix that, we'll do it with the /E so that I can edit my command in Vim, not having to do it on the command line since it's a multi-line long command. And what I'll do is I'll just add some nulls down here. There are 2 additional columns that I need to add to this bottom query so that it's the same shape as the top query. And so :WQ, do that, and we get this up here. So again, this command of, we have the join up top. And again, the join is like the in subclause, in subquery, but it's getting both the contents of both tables. Union all with the not in subclause down below gives us the left join between the 2 tables. Let's look back at the left join between A and B on the same condition, and we get the same answer right here. Questions about that, Joy?
If there was a situation where there were like a bunch of different nulls you have to add, is there a better way of kind of doing that same logic?
Yeah, this is a great question. So the question is right here, there were 2 nulls that I had to add to make the shapes of these tables match up. And what if there were like 1,000 nulls that I needed to add to make the shapes line up? Or it could even be the case that I might not even know what the shape is. Like I might not know how many columns are in this basket B table for whatever reason. And is there a way to automatically add the appropriate number of nulls down here? And the answer is unfortunately no. That these have to be manually added, and there's nothing that you can do about that. That's a system that would add these nulls for you sort of appropriately would be part of, in programming language theory, would call that like metaprogramming, that it sort of like would write the program for you. And SQL is super old, so it doesn't support any sort of metaprogramming. Modern languages, Python, C++, C even, do support that. Yeah, can't do that automatically. Again, semantically, both of these 2 things exactly the same. If on any of the given homework assignments, homework problems, you think it makes more sense to use the not in operator, you're allowed to do that. Or if you think it makes more sense to use the left join, you're allowed to do that as well. Yes, Dustin.
I might have missed this, but when you say you don't specify like left or right join, and you just say join, what's the default there?
Good question. So the question is, we said that we can have join by itself, and join by itself is equivalent to an inner join. All the other types of joins, so far we've only seen one other type of join, the left join. All the other types of joins are what are called outer joins, and basically outer is anytime the null is, you might have null rows added, null columns added. Those are outer joins, and this is a particular type of outer join called the left outer join. The next type of outer join is the right outer join, which is basically just the left outer join swapping the two different sides. So the right outer join, like this, is equivalent to the left outer join that we were doing before, modulo column order. So previously with the inner join, it was basically commutative, that it doesn't matter if you swapped the left and right. The left and right outer joins, you can swap them, swap the tables as long as you swap the left and the right. There's also a full outer join, which gives you the results of both the left outer join and the right outer join put together. And all of these outer joins, the outer keyword here is optional. You can omit it if you want, just like you can omit the inner from the inner join. In practice, it's 99% of the time, if people are using outer joins, they're using left outer joins. Very rare to use the other types of outer joins. Any questions about the joke?
I'm not sure I understand what's happening with the full outer join.
Sure. So the question is, what exactly is happening with the full outer join? And so if we have the left outer join, we can see that we have this, the inner join right here. This is the not in, all the fruit A, not in fruit B. Those are the same things we have right here in the full outer join. Here is the inner join right here. Here's the not in part. This is all of the fruit A not in the basket B. And if we do the right outer join, then we still have the inner join right here. And then this part right here, these are all of the fruit B's not in basket A. So if we go back to the not in command that we had before, these are the fruit A's not in basket B. I'm going to swap all the A's and B's. These are all the B's not in basket A. And if you look at the right outer join over here, because basket B is on the right, these are the fruit B's not in basket A right here. Now if we go do the full outer join, the full outer join is like the left outer join plus the right outer join. They both have the inner join part right here. These are the fruit A's not in basket B, and these are the fruit B's not in basket A. Good question. Any other questions at this point? Okay. So at this point, I know the joins may seem weird, and why would I ever want to use these things? Or like just I remember when I was first learning these joins, I probably relearned them at least a dozen times throughout my life, because yeah, it's just always so many small things to trip you up. You think you understand it, but then you see an edge case where you don't understand it. It makes you doubt your understanding of the whole world. And we're going to start taking a look at those edge cases here in a little bit. All of these things that we've seen so far are what I would consider the simple case. Before we see the weird edge cases, though, I want to take a look at some of the homework problems that use these simple cases so that we can get a little bit more intuition about when would you want to use these different join types. So now, in order to do that, I am going to put my two terminals back on the same screen like this. And down in the bottom one, let's see. So we have these 13 different problems right here. I'm going to start with, well, I'll start by opening up number 1 here. I'm not going to do number 1 here because the book has a solution to number 1. If you read through the textbook on the subqueries, it'll tell you how to do it. So you can look that up yourself if you want some help with number 1. And we'll start with number 2 right here. So the idea of number 2, so a film's rating can be G, PG, PG-13, any of these different numbers or different ratings. And we want to generate a query that returns the 2 most popular ratings. And then we will select the films and titles, basically all the films that correspond to the 2 most popular ratings. So I've sort of broken this up step by step here of generate a query that returns the 2 most popular ratings. So let's first figure out how do we get the ratings. Let's come back over to our chillograph over here. Under the film table, there is a rating column. So let's do a here select star or do select rating from film just to get a sense of what's going on. Here's our G's, PG's, PG-13s, all of those things. So we're on the right track. And we want to figure out what are the most popular ratings. So to get the most popular ratings, I'm going to, so rating, comma, count star, count all the ratings from film and group by rating like this. So we saw this query last class where we had the different ratings and the different counts. But these are not returned in any particular order at this point, so I need to get them ordered from most to least popular. So we'll do order by count. And this is going the opposite way. It's going from the least popular to the most popular. So by default, when we do an order by, it orders ascending, ASC for ascending. If I want to change it, reverse the order, I do DSC for descending. And now it goes from top to bottom. The 2 most popular are PG-13 and NC-17. And in order to make my query actually be the 2 most popular, let's add a limit 2 right here like this. Limit 2. So these are my, my 2 most popular ratings. If I want to, well, first of all, any questions about why this query gets the 2 most popular ratings? This like make sense? Why that worked? I see lots of thumbs up. So now what I need to do is I need to find all of the films whose rating is one of these 2 things right here. I could sort of, if I was being like evil to myself, lazy in the worst possible sense of lazy and like muggle non-computer science lazy, I could do something like select title from film where rating equals PG-13 or rating equals NC-17 like that. And this query would work, but it's not great because for 2 reasons. Well, the first reason is that this is just like super redundant right here. If I had, I don't know, like 20 ratings that I was needing to be searching for, then this would be a huge pain in the butt to type in over and over again. So the first thing we'll do is a way to simplify this a little bit. So that command works, but we can do a little bit better using the rating in syntax. Here, slightly new thing that we haven't seen before. You can wherever you have a subquery in the where clause, you can also just manually list out the contents of that table if you want. So here, PG13, NC17, we're rating in this. Hit enter, so that gives me the same results. So this is a little bit nicer because now if I have 20 different ratings that I need to enter, I only have to enter the actual ratings and not all of this other sort of boilerplate stuff. But it's still not super nice because it's not extensible, where if the number of ratings changes or if the popularity of ratings changes, then this query will suddenly become incorrect. So it's never a good idea to hard code things like this. And on your homework assignment, if you choose to hard code things, you're not going to lose points, but you're sort of cheating yourself out of writing a fully correct SQL statement that's going to like last forever, be robust, never have bugs in it. So what we need to do is we need to have our subquery return to us just these things right here. So how can we do that? We'll take another look at subquery features right now. So here's our query of the ratings. But what I need to do is I need to get only this column right here. If I were to put this whole thing inside of this right here, the in wouldn't know whether to do look at the rating or the count columns, and so we'd get a syntax error. Anytime you have a subquery that is using the in clause next to the subquery, you have to have just a single column in this subquery. So we need to reduce this down to a single column, just the rating column. One way to do that, wrap this whole thing in a subquery, and we can do select rating from this whole thing right here. So we can put a subquery in any location where we put a table. Select rating from this subquery. You're gonna hit enter. We'll get this slight syntax error. Anytime you substitute a table with a subquery, you have to name that subquery. Postgres does not allow what are called anonymous subqueries. Every subquery must have a name. And so my typical name for a subquery is just T because it stands for table, and I don't like typing out table. The most correct syntax, or the most verbose syntax, is we have this whole thing right here, as T, the as saying we're naming it. But the as is optional, so you can do that, or you can leave out the as T, and it's the same thing. So I normally just have my subquery, and then the letter T, and then there we go. And those are the ratings. Any questions about how I removed that column? That will be a super useful transformation for you to do to your tables as you're going through the second homework assignment, is removing columns. And so this is the way that you can do that, by wrapping it in a subquery, selecting only some of the columns. And now that I have this thing right here, I can put that into this thing right here. Since this is, I don't know, query's getting pretty long at this point, I'm just gonna go straight down to Vim down here and enter it in. So also maybe type it out in maybe a nicer little format. So we'll do select title from film where rating in, and then select rating from select rating, comma, count star from film group by rating order by. And just copying this up here. Order by count descending limit to, close that parenthesis, add name that subquery, close that parenthesis, and semicolon. And so this is, assuming I haven't made any mistakes, this is going to be the answer for this problem. In order to check it, we'll start by doing set no number, so I can copy and paste this SQL from Vim down here into the pSQL session up above. Paste that here, hit enter. Okay, that seems like reasonable results. Let's come down here and check it doesn't mention, it says order by title. So let's make sure we add an order by title. And maybe, so what I'm going to do next, I'll actually run the grading script. But before I do that, are there any questions about how I got this sort of big monster query down here? Yes.
Could you clarify why we don't have to name them the outer query?
Let's see. So we have two subqueries in here, and the question is, why do we name one but not the other? It's a great question. So, so specifically, there's a subquery right here that requires a name, and a subquery out here that does not require a name. Technically, in Postgres, any subquery that can be referred to from another part of the query must have a name. And so this query right here can be referred up here. Like if there were, maybe I join this on something else, join it on film. Well, the film table already has a rating column. And so how would we know if we were trying to get the rating from this subquery or the rating from this film down here? And the answer is we would do something like t.rating. Because again, anytime we have something to the left of a dot, it means that this is the table name. This over here to the right is the column name. And so t.rating is exactly the same as just rating. Because rating is not ambiguous, you can leave out the t-dots. In general, anytime you're putting a subquery in the from clause or inside of a join clause, you'll have to name that subquery because you can refer to it in the column list up here. In this outer subquery though, this one right here, the only place this subquery can be used or referenced is right here. It can't, this subquery right here is only for this in clause, can't be referenced anywhere else. And so because of that, it does not require a name. Question?
So I was just thinking, is there any way you can just select function and just select the name and order by control at the bottom?
Oh, yeah, great question. So the question is, here, so we have two subqueries. Is there a different way that I could have done this? And the answer is yes, that this query right here, I'm going to copy and paste this query up here like that. Needs the name like that. That query is equivalent to another query that looks like select rating from film, group by rating. So we can do this, and this will give me the ratings, but it doesn't give me the counts at all. And I can do an order by count star like this. Now it's ordered, order by count star descending. Now it's in the order we want, limit 2 like that. And now we've done the this query right here with only a single select, no subqueries, is equivalent to this query right here that contains the 2 selects with the subquery. So in general, there are many possible ways to complete any of these homework assignments, and whatever makes sense to you is fine. We will talk about performance implications of the different choices in about 2 weeks. Yes.
This wouldn't work if we selected 2 comments, like we wouldn't know what to count.
So the way that it knows, yeah, so the question is, what if there were multiple columns that we were doing this by? So it knows what to count by what we have as the group by over here. So if we had select rating and see if we can find a different thing, we'll try release year, rating and release year from film group by rating, comma, release year. Now that works, still the same ratings from 2006. But yeah, so yeah, this is what tells it what it should be like counting. If we can take away the limit just to verify that. And there they are. Here, I guess all the release years happen to be just 2006. So it's not a super interesting column to group by, but that's the syntax. All great questions so far. The next thing, our next step is to plug this into the checking script. And so let's go ahead and do that here. SQL, go into bash, / check answers, and everything is failing. Let's see, we were on problem 2, still failing. Down here, open that up again. Open up the expected o2.out and tabby results o2.out. And so we can see that the expected just has this extra column over here. I think if we read this more carefully, saying it wants both the film ID and the title columns. So we'll change this to film ID, title like that. And hopefully, yep, now that passes on number 2. Any questions about problem number 2? So this was, again, just subqueries without talking about the joins. Okay, then we'll try another problem that's using the joins. I think number 5 is the one that we want to do. Yeah, so this one can be solved using either the left join or the not in operator, and we'll do it both ways and see which one makes the most sense to us. So here, management wants to advertise 2 actors who are renting movies, and so it needs a list of all the actors who are not customers, because if somebody's already a customer, then who cares? We don't need to advertise them. We want to get new customers. And so we want a list of all the actors who are not customers. There's 2 tables that we'll be using. There is this actor table right here, and there is a customer table up here. And normally, at least in the first homework assignment, anytime you're joining between tables, you'll always be joining along these lines. But here, this join is going to happen not along, or we're going to be comparing actor and customer, not using any of the intermediate tables. Instead, it's telling us just to look at the first name and last name of the 2 tables, and that if somebody shares a first name and last name, then we assume it's the same person. So not a good assumption in real life, but the sort of assumption that businesses make all the time to make their life easier. So let's first, so yeah, our goal, a list of all actors who are not also customers. So we'll start by just listing all the customers. Select first name, comma, last name from customers, like that. So, oh, I'm in bash, not P-SQL, that's why I was getting errors. So there we go. First name, last name, and so on. And then actor as well. There we go. We could find all of the actors who are also customers by using a join. So select first name, last name from actor, join on, or join with customer on first name, and we'll do the using first name, comma, last name, like this. And this gives us all of the customers who are also, or all of the actors who are also customers. Here, so this is a slightly new thing that we haven't seen before. We're joining on two different columns right here. Again, anytime you see this using syntax, then you can desugar the using syntax. What that looks like desugared is changing this using to an on, and then first name actor dot first name equals customer dot first name actor dot last name equals customer dot last name. Let's see, getting an error message. Perhaps I meant to reference the column customer.first name. Do I have a typo? Yes, I do have a typo. It's hard to see. It's going off the edge right here. I have first aim instead of first name. First name like that. Oh, and then here, instead of a comma on the on, it should be an and like that. Oh dear. And then we're getting this first name, last name is ambiguous over here. When you use the on like this, over here, it's going to give us, we can reference both of these tables, the actor table and the customer table, and so we'll need to qualify which one we're referring to. They happen to be guaranteed to be the same. The SQL doesn't know that. And so we'll do actor.first name and actor.last name like that, and that gives us the same results eventually. So desugared this, got the really complicated thing, handful of error messages along the way, but it's the same thing. Any questions so far? Okay. Then now that we have the name of somebody who's in both, or we have sort of a formula for finding somebody who's in both, there's a number of ways that we could try to get the people who are, what do we need? We need actors who are not customers. So we could do a select actor name, not actor name, first name, comma, last name from actor like this. And then we could use a set operation. So this gives me all of the actors, but then I could subtract off this particular actor right here. The set operation that does that is except. Except does sort of like subtraction, give me all of these things on the left except the things on the right. And I can copy and paste my query over here that gives me all the actors intersected with the customers like this. And if I do that, that is a correct way of giving me all of the actors. Go ahead and copy this down here. This is one method of giving me all of the actors who are not customers. Make it a little bit easier to read. Putting it on multiple lines like this. There we go. So this is only one way of doing it. This is actually not using either the left join or the not in. It's using our set operation. Now let's use the left join. So I'm going to join the actor table and the customer table. So select first name, comma, last name from actor, left join customer using first name, comma, last name. I'll go ahead and run this first. And you see there's a lot of actors who are not customers, and this is giving me it's giving me everybody's name because it's there's no extra columns over here that I selected. So we want first name, last name, and we'll do customer ID like this. So here's the one person who is a customer. They have a customer ID. Everybody else is null. And so I can add a where clause where customer ID is null like this. And now it's filtered everybody out. Jennifer is no longer listed here. Let's compare these two commands. Here we had where customer ID is null. So everything is null. Then up here, customer ID not null for Jennifer Davis. And so we wanted to remove her because she's in the customer table. So this command also same as the previous command. Either way would be a fine solution. I think we're out of time, so next time at the start of class, we will see the third solution using the not in operator. And then we'll go into the weird edge cases of these joins and how they relate to your take-home assignments. If anybody else has other questions, then happy to stick around and answer them. Again, also have office hours today from starting at 1 o'clock. And either right now or during office hours, you're welcome to take that post-6 quiz, retake it if you'd like. So, see you all later.